Good morning, students, and a very warm welcome to the digital teaching learning program. Students, we have started lesson number 5 towards green energy, and as I told you that it's quite an interesting and of course a lengthy lesson. There are so many power plant in this lesson where the electrical energy is generated with the help of different raw materials like wind, water, solar energy, etc. So, let's continue with the last part of the lesson. We had studied electricity generation in this lesson, and we had studied how the electricity is generated by the different power plants. The latest we had studied is the hydroelectric energy power plant, where the water is stored in the dam and the potential energy of stored water is converted into kinetic energy when it is flown from a higher level with great speed, and due to this kinetic energy of water, the turbine starts rotating, which in turn moves the generator, and the generator generates the electrical energy. And the schematic representation is potential energy of water converted into kinetic energy. This kinetic energy turns the turbine, and in turn the generator generates the electrical energy. Now today we are going to start with the new power plant, that is electricity generation using wind energy. Now, this has been used since ancient times. The wind energy, the kinetic energy of the wind energy is used since long. Now, this wind energy is also used for electricity generation. And the machine which converts the kinetic energy of wind into electrical energy is called as the wind turbine. It is like a turbine, it is having the blades, and it is called as wind turbine. So when the wind with a high velocity rotates the turbine starts moving. This turbine is connected to the gearbox, and this gearbox increases the rotation of the turbine blades, and which runs the generator, and in turn the generator generates the electricity. If we see the schematic of windmill, we can see that the blades of the wind turbine is there, and the shaft is connected to the gearbox, and in turn the gearbox shaft is connected to the generator. The only condition is that the wind turbines are to be installed at such a place where the velocity of the wind is very high, and the wind velocity, it depends upon many geographical factors. Now generally the velocity of wind is very high on the seashores, and there the installation of wind turbine is done. Now as there is no artificial fuel is used in this, it is the natural source, that is wind. So wind energy is a very clean energy source. But the only limitation is that the wind velocity of required speed is to be required for this rotation. So only at very limited places the wind energy can be generated. So the transformation of energy in an electric generator using wind energy is very simple. The kinetic energy in the wind rotates the turbine. That is, the kinetic energy is used to turn the blades of the wind turbine, which in turn moves the generator, and thus the electric energy is generated. Now, as I told you that the required velocity of wind is needed for the moving of the wind turbine. And these windmills, they are as per the geographical locations. Their size is different, their capacity is different. Like you can see in the picture, the one which can be installed at the residential places, they have the blades of 1.5 meters and their capacity to generate electricity is only 2 kilowatts. Whereas in the wind farms, the size of the blade is almost 50 meters and the capacity is also more. Whereas the offshore wind turbines, if you see, the size is quite big, they are very tall, and the length of the blades are 100 meters, and their capacity to generate the electricity is 6,000 to 7,000 kilowatts. Can you tell me, in Virar, have you ever seen these wind turbines? Yes? Think high and think of Jeevdani. Yes, yes. There you can see the wind turbines are installed. Next we are going to study is the electric energy generation using the solar energy. Now this can be done by two different methods. In the first one, the solar radiation energy or the solar energy is directly converted into electrical energy with the help of a special type of cells which are called as solar photovoltaic cells. And in the second method, first the solar radiation is converted into thermal energy and then this thermal energy is used to generate the electricity. Okay, so first of all, we will start with the first method where the solar radiation energy is directly converted into electrical energy. Now this is done by using special type of cells which are called as solar photovoltaic cell, and these cells, they convert the solar radiation directly into the electrical energy, and this effect is called as solar photovoltaic effect. Now this electrical energy which is generated through these solar cells or the solar photovoltaic cell, it is DC in nature. DC means direct current. Students, you might have heard about DC and AC, right? So DC is the direct current and it is only one direction, or it flows in one single direction where the electric charge is unidirectional, right? So direct current, it may flow through a conductor such as wire, and it can also flow through the semiconductors like insulators or silicon, right? So this is the DC current, and the other one is AC current, that is called as alternate current. This current periodically reverses direction and changes its magnitude continuously with the time. Okay, so this is the major difference, that direct current flows in only one direction, whereas alternate current, it changes the direction continuously. Now with the help of the solar photovoltaic cell, the current that is generated, the electricity that is generated is DC in nature, or it is the direct current. If we see the energy conversion, it is just one step. Through the photovoltaic effect, the energy in the sunlight, the solar radiation energy, is converted into the direct current or DC electric power. Now these photovoltaic cells or the solar cells, they can be connected to each other in two methods. In the first method, they are connected in series, right, one after the other, whereas in second type they can be connected in parallel form. This you had studied in your 9th standard, the parallel and in series. So here, when the solar cells are connected in a series, the potential difference that is obtained from this combination It is the addition of the potential difference of individual solar cells, right? That is, the total potential difference is equal to the addition of potential difference of individual solar cells. But the current generated from this combination is equal to the current from an individual cell. Okay. So it means that when solar cells, the photovoltaic cells are connected in series, currents from the individual cells are not added. Whereas when they are connected in parallel, the current which is generated from the parallel combination is the total of the currents from an individual solar cell, right? So the potential difference that is obtained from the combination of these cells in parallel condition, it is obtained as same as from the individual cell. So if the two solar cells are connected in parallel, the potential difference from the two cells are not added. Whereas in series, the potential difference of individual solar cells are added. So these are the two ways by which the solar cells can be connected to each other. They can be either connected in series, right, where the current generated is equal to the current of an individual cell. In the second one, they can be connected in parallel, but here the potential difference from the two cells are not added. Okay. So this is how the solar cells are connected to convert the solar radiation energy directly into the electric energy. So in this way, the solar cells, they are connected either in series or they are connected in parallel condition, and the required amount of electric current and potential difference can be generated. Now in the picture you can see there are 36 photovoltaic cells which are placed in a series, right? They are connected in a series and thus the electricity can be generated on a larger scale. Now, if we have this solar cell and it is quite good, then it has the efficiency of around 15%. That means if the solar panel, this whole panel receives the power of 100 watt from the solar radiation or from the solar energy radiation, the electrical power output from this solar panel will be 15 watt. So 15% will be converted into electrical energy. So in this way, many solar panels are connected in series as well as in parallel to generate the required amount of electric current as well as the required amount of potential difference. Now in the picture you can see that a solar cell is made. Now the solar cell is the basic unit in a solar electric plant. Like we had studied that cell is the basic structural and functional unit of any organism. Similarly, here the solar cell, it is the basic unit in the solar electric plant. So many solar cells, they are connected in a series and then they are connected to form a solar array, that is called as a solar array, and we can obtain the electrical power as required with the use of this application. And the electrical energy that is generated, it can be of marginal power which can be used to run the calculator, and it can be in huge amount as to run the power station. Now the energy which is converted, the solar energy that is converted into the electrical energy, that is in the form of DC, that is the direct current, right? So if we are using an equipment which runs on DC, then we can directly use this electrical energy. But if the equipment works on AC, that is alternate current, then first it has to be converted into AC and then it has to be supplied to the electrical equipment. So when the solar cells, they convert the solar radiation into the electrical energy, first it is to be stored in the batteries. Why? Because now the sunlight is only available during the daytime, right? So the solar radiation we are getting only in the presence of the sunlight. So this has to be stored, and this electrical energy is stored in the batteries so that it can be used in the whenever it is required. Now this battery is connected to the inverter, which converts the DC into AC, as the most of the equipments, domestic equipments which we use, as well as in the industries also, they run on the AC power. So it cannot be used directly, it has to be converted, the direct current has to be converted into the alternate current, which is done by the inverter, and then from the inverter it is supplied to the electronic device, right? So this is how the conversion of energy is done, and the electrical energy is generated by the solar cell. Now if we see the schematic of solar photovoltaic station, we can see in the picture that many solar panels, they are connected together to generate the electrical energy. Now here first, as I said, the electrical energy is generated in the form of DC, that is the direct current, right? So it is stored in the batteries, then it is sent to the inverter where it is converted into AC or the alternate current, okay? And a transformer is also there which transforms the voltage and the current levels of the generated power, and then it is distributed to the different areas. Sorry. So in this way the electricity is generated. The next second power plant which we are going to start is the solar thermal power plant, where the solar energy is used to generate the electricity. In the first one we had seen that directly the solar energy radiation is converted into electrical energy with the help of the photovoltaic cell. Now this is the second method by which the solar energy radiation is used to generate the electricity. Now this plant is almost same as the earlier ones where we had studied that the thermal energy generated from the coal, from the nuclear fuel, from the natural gas, and then it is used to generate electricity. So from solar radiation also the thermal energy is generated and then it is used to generate the electricity. So the solar thermal power plants are the electricity generation plants which utilize the energy from the sun, the solar radiation from the sun, to heat a fluid to a very high temperature. And then this fluid, it transfers its heat to the water, and then water, when it is superheated, it gets converted into steam, and then it is used to run the turbine, and turbine runs the generator, and then the generator in turn generates the electrical energy. So there are concentrators which collect the sunlight, then they have the absorbers which absorb these concentrated solar energy, and then it is converted into steam, and then steam runs the turbine in turn runs the generator, and in turn at last the electrical energy is generated. So here the electricity is generated by concentrating the sun's energy. Now this is the schematic of solar thermal power plant. The much explanation is not given in the textbook, so only diagram you have to remember, and in short you can explain it. There are reflectors which reflect the solar radiations, and the concentrator are there which concentrate this solar radiation, and it is absorbed by the absorbers, and the hot water is flown through it, and this water is converted into the steam due to the very high solar radiations, and then this steam is used to run the turbine in turn runs the generator, and the electrical energy is generated. And like in the earlier power plants we had seen, the steam is again passed through the condenser, where it again condenses and converts into the liquid, and again it is allowed to pass through the absorbers. Again this cycle goes on. So this is how the solar thermal power plant works. This is just for your information that the energy sources which are used for the electrical power generation in the world, we are talking about the whole universe, and it is compared with India. Coal is used around 41% in the world, whereas it is used 60% in India. Natural gas 22% in world and 8% in India. Hydroelectric 16% in world, and in India it is only 14%, but much better than other plants. Nuclear energy 11% in world, whereas only 2% we are using in India to generate electricity. Petroleum 4%, whereas in India it is only 0.3%. Renewable sources like wind and solar, etc., only 6%, whereas in India we are using it up to 15.7%. So that's quite good because we are using the renewable sources. Okay, so this is the data which is given in the textbook. So students, we have finished one of lengthiest lesson of our syllabus towards green energy. In this lesson we had studied the different power plants for electrical energy, generation of electrical energy. Now next time, in the next science lecture, we are going to start with the textual exercise of the same. So I request you students, please try to find out the answers of the textual questions so that it becomes easy for you to tick mark the answers in your textbook. Students, please take care of you and your family. Stay home. Stay safe. Thank you.